Hi, my name is Antonio Fuentes and I'm going to talk about 6 processes to change the shape of materials. Number 1. In the permanent mold casting process, also called gravity die casting, a reusable mold is machined from gray cast iron, alloy cast iron, steel, bronze, graphite, or other material. The molds are usually made in segments which are often heightened to permit rapid and accurate opening and closing. After preheating, a refractor or mold coating is applied to the preheated mold, and the mold is clamped shut. Molten metal is then poured into the pouring basin and it flows through the feeding system into the mold cavity by simple gravity flow. After solidification, the mold is opened and the product is removed. Since the heat from the previous cast is usually sufficient to maintain mold temperature, the process can be immediately repeated with a single refraction coating serving for several pouring cycles. Aluminum, magnesium, zinc, lead, and copper-based alloys and the metals most frequently cast, along with the gray cast iron. If graphite is used as the mold material, iron and steel castings can also be produced. Number 2. Rolling operation. Rolling operations reduce the thickness or change the cross-section of a material through compressive forces exerted by rolls. Thick starting stock can be rolled into blooms, billets, or slabs, or these shapes can be obtained directly from continuous casting. A bloom has a square or rectangular cross-section with a thickness greater than 15 centimeters and a width no greater than twice the thickness. A billet is usually smaller than a bloom and has a square or circular cross-section. Billets are usually produced by some form of deformation process, such as rolling or extrusion. A slab is a rectangular solid where the width is greater than twice the thickness. A slab can be further rolled to produce plate, sheet, and strip. Plates have thickness greater than 6 millimeters, while sheet and strip range from 6 millimeters to 0.1 millimeters. Number 3. Forging. Forging is a term applied to a family of processes that induce plastic deformation through localized compressive forces applied through dies. The equipment can take the form of hammers, presses, or special forging machines, while the deformation can be performed in a temperature regimes cold, hot, warm, or isothermal. Most forging is done with the workpieces above the recrystallization temperature. Forging is clearly the oldest known metalworking process, from the days when prehistoric peoples discovered that they could heat sponge iron and beat it into a useful implement by hammering with a stone. Forging has been an effective method of producing many useful shapes. Modern forging is a simple an extension of ancient art practiced by the armor makers and immortalized by the village blacksmith. High-powered hammers and chemical processes have replaced the strong arms and they supplement the art and skill of the craftsman as we seek to control the heating and the handling of the metal. Parts can range in size from ones whose largest dimension is less than 2 centimeters to others weighing more than 170 metric tons. Number 3. In the extrusion process, metal is compressed and forced to flow through a suitable shape die to form a product with reduced but constant cross-section. Also, extrusion may be performed either hot or cold. Hot extrusion is commonly employed for many metals to reduce the forces required, eliminate cold working effects, and reduce directional properties. Basically, the extrusion process is like squeezing toothpaste out of a tube. In the case of metals, a common arrangement is to have a heated billet placed inside a confining chamber. A ram advances from one end, causing the billet the first upset and conform to the confining chamber. As the ram continues to advance, the pressure builds until the material flows plastically through the die and extrudes. Number 4. Bending is the plastic deformation of metals about a linear axis with little or no change in the surface area. Multiple bends can be made simultaneously, but to be classified as true bending and treatable by simple bending theory, each axis must be linear and independent of the others. If multiple bends are made with a single die, the process is often called forming. When the axes of the formation are not linear or are not independent, the process are known as drawing and or stretching. Simple bending causes the metal on the outside to be stretched while that on the inside is compressed. The localization that is neither stretched nor compressed is known as the neutral axis of the bend. Since the yield strength of metals in compression is somewhat higher than the yield strength in tension, the metal on the other side yields first and the neutral axis is displaced from the midpoint of the material. The neutral axis is generally located between 1/3 and 1/2 of the way from the inner surface, depending on the bend radius and the material being bent. Because of this lack of symmetry and the dominance of tensile deformation, the metal is generally thinned as the bend. In a linear bend, thinning is greatest in the center of the sheet and less near the free edges, where inward movement can provide some compensation. Sheet hydroforming is really a family of processes in which a rubber bladder backed by fluid pressure or pockets or pressured liquid replaces either the solid punch or female die of the traditional tool set in a variant known as high pressure flexible die forming or flex forming. The rubber pad of the wearing process is replaced by a flexible rubber diaphragm baked by controlled hydraulic pressure at values between 140 and 200 MPa. The solid punch drives the sheeting to the resisting leather whose pressure is adjusted throughout the stroke. In a variation of this process that shares similarity to stretch forming, the sheet is first clamped against the opening and the punch is retracted downward. The fluid is then pressurized, causing the workpiece to balloon downward toward the punch. Since the pressure is uniformly distributed over the workpiece, the sheet is uniformly stretched and uniformly tightened. The punch then moves upward, causing the pre-stretched metal to conform to its profile. The number 6. Thick walled seams tubing can be made by rotary piercing. Heated billet is fed longitudinally into the gap between two large convex tapered rolls. These rolls are rotated in the same direction, but the axes of the rolls are offset from the axis of the billet. by about 6 degrees, one to the right and the other to the left. The clearance between the rolls is preset at a value less than the diameter of the incoming billet. As the billet is caught by the rolls, it is simultaneously rotated and driven forward. The reduced clearance between the rolls forces the billet to deform into a rotary ellipse. Rotation of the elliptical section causes the metal to shear above the major axis. A crack tends to form down the center axis of the billet, and the cracked material is then forced over a pointed mandrel that enlarges and shapes the opening to create a seamless tube. The result is a short length of thin-walled seamless tubing, which can be passed through sizing rods to reduce the diameter and/or wall thickness. Seamless tubes can also be expanded in diameter by passing them over an enlarging mandrel. As the diameter and circumference increase, the walls corresponding thin. Now we wanna show um, a little examples of each process. Finally, we wanna see some examples of each process. This is an example of mold cast process. Truck and car pistons are mass produced by the millions using permanent mold casting. Rolling operation example: flowchart for the production of various finished and semi-finished steel shapes. Note the abundance of rolling operations. Forging process: a forged and machined automobile engine crankshaft that has been formed from microalloyed steel. Performance is superior to cranks of cast ductile iron. Extrusion process: typical shapes produced by extrusion. Piercing process: principle of the Mannesmann process of producing seamless tubing to produce billets. Bending process: schematic of the roll bending process. The material is continually subjected to 3-point bending. For example, this is a metal sheet. Hydroforming process: use the hydroformer tubes in automotive applications. And that's it. Thank you.